Hello everybody! In this video I would like to continue my overview of Git commands and the collaboration capabilities that Git offers. Let me remind you that in the previous part we created the Git study remote repository on GitHub. We also created the local repository using the git clone command. Additionally, we covered the commands listed on this slide, which I will be using in this presentation without further explanation. Let's continue working in the repository that we created in the previous part of the presentation. As you remember, we should work independently to not affect the existing code base. To do this, we need to create a separate branch for our task and switch on it. Open Git Bash and use the cd command to navigate to the local repository. Then let's create a separate branch in Git Bash using the command git checkout -b task11. Let's agree that for this presentation, the task11 branch will be considered my working branch. Let's navigate to GitHub. We see only the main branch because we have just created the task11 branch in the local repository and have not pushed it to the remote repo yet. To make task11 branch available for the whole team, we should push it. Let's do it using Git Bash. As you remember, when we push a new branch the first time, we need to set the remote as upstream. The Git Bash suggests which command should be used. Now we can see the task11 branch in the remote repo. We have just covered how to create a local branch and add it to the remote repository. Let's consider the reverse situation where a colleague has created their branch and pushed it to the remote repository. And we need to make our local repository aware of new remote branches. Let's agree that for this presentation, the task12 branch will be considered the working branch of my colleague. We can simulate this scenario by creating task12 branch directly in the remote repository. To do this, click Branches on GitHub, then click the New Branch button, fill in the New Branch Name field, task12, select the source branch from the drop-down list, and click Create New Branch. Files in this new branch will be identical to those in the source branch. Next, let's make a change to one of the files in the task12 branch, for example, the README file. To do this, click on the README file and then click the pencil icon to edit it. Let me remind you that for saving changes, we should use a commit. Commit is a wrapper for some set of changes. After making the desired changes, click on Commit Changes button and provide a commit message, study fetch command. Select Commit directly to the task12 branch and click Commit Changes. Let's go back to Git Bash and check what branches we can see using git branch -a command. The A flag displays all branches, so we should see the list of both remote and local branches which our local repository is aware of. We see the main and the task11 branches in the local and the remote repositories. we don't see any information about the task 12 branch that has been just created in the remote repository. To make our local repo aware of new branches and changes from the remote repository, we should use a git fetch command. Let's do it. Now repeat git branch -a command, and we can see that our local repository is aware of the task 12 branch from the remote repository. So if we need to work on task 12 branch, we can switch on it. Let's examine the task 12 branch. First, switch to this branch using the git checkout task 12 command. Then use the git log command to view the commit history. The git log command provides a history of all commits, each with its own staging index SHA, also called a hash, author, date, and commit message. The latest commit should contain information about the most recent modifications in this branch, such as the study fetch command commit message. So you can see the local repository has got task 12 branch, and the branch contains all the commits that have been made before. Now let's consider another scenario. Suppose we already have the task 12 branch in the local repository, and we want to receive updates from the remote repository made by our colleague. We can simulate this by making changes in the task 12 branch on GitHub. Navigate to the task 12 branch in GitHub and make a change to the index file, providing a commit message. For example, study pull command. Return to Git bash and execute the git log command to view the commit history. Notice that the last commit in the local repository is study fetch command, which is not the latest commit in the remote repository. The latest commit should be study pull command. Let's execute the git status command to check the branch status. You will see that the branch is up to date because our local repository is not yet aware of the changes made in the remote repository. To make the local repository aware of the changes in the remote repo, we should apply git fetch command. Let's do it. Now repeat git status command, and we see that the local branch is one commit behind remote repository. So git fetch command makes your local repo aware of the actual state of the remote repo, including new branches and commits. But git fetch doesn't apply any changes to local branches. To incorporate changes from the remote repository into your local repository for task 12 branch, use git pull command. Let's repeat git status command to confirm that the local branch is up to date with the remote branch. Finally, execute the git log command to verify that the local branch now contains the latest commit, study pull command, from the remote repository. So we made some changes in the remote branch, made the local repository aware of these changes, and pulled the changes to the local branch. To get the updates from the remote branch to the local branch, we should use git pull command. This command works for the current branch only, so don't forget to switch to the proper local branch before executing git pull. In summary, git fetch makes your local repository aware of the changes in the remote repository, while git pull updates your current local branch with all new commits from the corresponding remote branch. Let's consider the next scenario. After doing a code review on your colleague's branch, you forgot to switch to your branch and started working with some files. You made some changes before realizing it and want to switch to your branch and continue your work there. Let's simulate the situation. As you can see, we are on the task 12 branch. This is our colleague's branch. Open the start file and make some changes to this file. Then execute the git status command to verify that the file is modified. Now our task is to transfer these changes to our branch while leaving the file unchanged in the colleague's branch. To achieve this, we should apply git stash command. Git stash command takes your uncommitted changes, both staged and unstaged, saves them away for later use, and then reverts them for your working copy. Let's do it. Repeat git status command to confirm that there are no changes to commit. And now we can switch to another branch. Let's do it. So now we are on task 11 branch. Let's get the branch status to ensure that your branch is up to date. Then apply the previously stashed changes using the git stash pop command. And we see that start file is modified. Open this file to verify that all your changes have been successfully applied to your branch. Now you can continue working on your task in your branch without affecting your colleague's branch. You can use the git stash command multiple times in any branch. In such cases, it's helpful to provide a comment for each stash to uniquely identify it. However, for the purpose of this presentation, we will not explore these advanced examples. For more information on git stash, you can refer to the following link. So we have just considered how to move changes from one branch to another using git stash command. On the slide, you can see all the commands we used today and short description of them. In this presentation, we covered several essential Git commands and collaboration capabilities, including how to create and add the local branch to the remote repo, create the remote branch, make the local repository aware of a new remote branch, and then pull remote branch changes into the local repository. Save uncommitted changes for later use and apply these changes to another branch. I hope this overview has been helpful for you. To be continued. Thank you for your time.